All right, superstars. I just have one more quick thing to teach you from lesson 1.3. So again, some of these problems are coming directly from your assignment, so hopefully you'll be able to get that homework finished a lot quicker. And then you have a little bit more review before your chapter 1 test. All right, so if you remember, our goal is to simplify our problems first. So that means on problem number 1, I'm going to go ahead and notice on the left side, I've got like terms. I'm going to go ahead and do that combining there. So 2x plus 2x is 4x plus 2. Wait a minute. Whoa. 4x plus 2 equals 4x plus 2. Now, what this is called here is an identity, because if you notice, they are identical. It's called an identity. If I were to move my variable, but wait a minute, they're the same size, so if I subtract 4x on both sides, I'm going to get 2 is equal to 2, an identity, because they are identical. So again, that is called an identity. But there's a few ways that we can write our answer. One way is this phrase here, all real numbers, which means that every value that I can think of for a real number, that's a fraction, decimal, integer, root, and so on, if I were to do my substitution and the check over here, everything would check out. So I can plug in a positive 2, work it out, checks. Negative 2, checks. A decimal, checks. Everything will check out because it's an identity, all real numbers. Another way to write this is called infinitely many solutions. So instead of all real numbers, you can say infinitely many solutions. Because again, you could keep coming up with more and more numbers that would make it true. Excuse me. Fractions, decimals, roots, and integers, and so on, a lot more. All right, so that means I'm done. There's nothing else that I can do because it is infinitely many solutions. All right, let's try this one here. Okay, let me combine like terms. I've got a 4x, a 2x. So that gives me a 6x plus 2 equals a 3x subtract 7. Now, if you notice, the variables are not the same, which means it's not going to give me a special answer. On our previous one, the variables were the same, 4x and 4x. This is 6x and 3x. So it's really just another repeat problem. So let's subtract 3x. 6x subtract 3x, 3x plus 2 equals negative 7. So when I continue on, I will be able to solve for my value of x. I'm not going to require the check. I'm just going to ask if you'd like to do it. Remember, it's a great test-taking strategy, and it's your grade. So if you'd like to check it, you'd come over here, you'd do your substitution. So again, 4 times x plus 2 times x plus 2 is equal to 3 times x. Oops. And subtract 7. I'll use a different color for the x value, which is negative 3. Again, I think the check is very, very helpful to see if you can get correct answers. Again, it's a way to check to see your thinking, too. 4 multiplied by negative 3 is negative 12. 2 multiplied by negative 3 is negative 6 plus 2. So negative 12 subtract 6 is negative 18, because you could really do adding the opposite. And negative 18 plus 2 is negative 16. Over here, 3 times negative 3 is negative 9. Subtract 7, which is really adding the opposite, gives me 16 negative. So the check is excellent. Again, if you don't want to do that, I'll let you make that choice. All right, a little bit of distributive property, maybe combining like terms, and we'll see what happens. So 2 times x is 2x. 2 times 2 is 4. Add 1. Combine like terms. 2x plus 5. Over here on the right side, 2 times x is 2. Wait a minute. I'll just skip down here. And 2 times 4 is 8, because there's no combining like terms in that one. Okay, so let me zoom in a little bit. Now, if you notice on this one, the variables are the same, which means it's going to be a special answer. But compared to our first problem, this was an identity because 4x plus 2 is exactly the same as 4x plus 2, just like identical twins. You know, I know you're not exactly the same, but you're relatively very close. So this one, 2x and 2x, yeah, those are the same, but if you notice, 5 and 8 are not. So if I were to go ahead and move the variables by subtracting, at least on this problem, I would get 5 is equal to 8. Now on problem 1, I had 2 is equal to 2. That was still an identity. This time, 5 is equal to 8, which is a false statement. That is not true, which means no solution. That's the only answer. Which means there is no value for x that would make this true at all. So if I substitute in 2, remember it has to go for both x's, so that would be a 4 plus 5, 9. And then on the right side, that'd be a 4 plus 8, 12. It's still not going to be equal to each other. It could be a fraction, decimal, root, integer, anything, and it's still not going to work out. So very similar, 2x and 2x, but these integers, 5 and 8, different. So no solution. And students actually like those problems because it's less work involved. One year I had a student, though, every single answer he wrote no solution. He's like, I got one right. Yeah, don't do that. All right, jumping to a word problem. A phone company offers 2 plans. Plan A has a monthly fee of $15.25 per minute. Plan B has a monthly fee of $20.05 a minute. I know this isn't necessarily the right context because of plans, the way they're structured, but hopefully you understand. Now, if you didn't like phone companies, you could talk about per mile, like renting something. Write an equation to find the number of minutes that you must talk to have the same cost for each plan. Let m equals the number of minutes. So essentially, we're writing an equation where they are equal to each other. So it would be company A is equal company B. So company A equals company B. It says let m equals the number of minutes. So on plan A, company A, it's $15 plus 25 cents per minute. M is the minutes. It could be miles for a different problem for all we know. Company B, $20 plus 5 cents per minute. So that is part A. I wrote an equation. Part B, solve it. So really just continue on. Again, the key is setting them equal to each other. And we're going to do that later on in chapter 8 when we are solving volumes, and they're going to have equal volumes. So practicing right now will help us later on as well. So remember, I'm going to go ahead and move the smallest variable. Both sides. So that's going to give me 15 plus 20 cents per minute, right? Is equal to 20. All right, I go ahead and subtract 15 both sides. Again, I'm solving for m, which is minutes, which is part B. Now, if I'd like to, I can change this into a fraction. So 0.20, if you need to, you can see it over here, is equal to 2/10, which is really equal to, in the reduced form, 1/5. So I could say 1/5 m. All right, from here, again, I'm going to practice the multiplying by reciprocal. Where m is going to be the number of minutes, where the company charging will be exactly the same for company A and company B. So 5 times 5 is 25, so 25 minutes. Part B, solve it. Just did. Nice. And again, if I want to check it, I can plug it back in and see if it comes out to the same cost. Again, it didn't ask to figure out the cost, it just wanted you to solve for the number of minutes. If it wanted you to find the cost again, since they are equal, you could say, okay, that would be company A, because you might have this on your test. That would be $15 plus 25 cents per minute. And I'm doing 25 minutes. So you can do your quarter counting and figure it out. Add them up, and that would be your cost. Hey, looks like we are done there. Again, quick problems helping you out. Your goal is to finish the remaining problems, and then you also have an additional review to prepare for your Chapter 1 test. All right, be awesome.